Hello. Oh.
Hello.
Hi, Skylar. Hi, William. William. Oh, hi. Oh, man. Not even. Where are we? It's 11. Hello?
Yes.
Okay. We're still on chapter 11. Hmm. All right. There we go. Hmm? Why is it not active? Huh? Some reason I cannot. I cannot. Let me restart. Give me a second. What the heck? What's happened? I cannot share my desktop for some reason. Huh. Okay. Oh, I had to join it. So weird. What? What is it? Something funny. Still cannot share my desktop for some reason. What happened? Some technical issue. Okay, let me end one more time. And some reason I cannot.
Because William got into the call first.
Really?
Yeah.
Yes.
He needs to restart.
Yeah. Hold on.
So we didn't get it? Really? That's
Yeah.
so funny. Huh?
Yeah.
Oh, you get that one. Oh, you. Oh, somehow you can transfer that to me. Oh, okay, now I am. Okay, all right. Okay, here we go. That's so funny. How come that happened? That can happen, huh? All right, here we go. Now, where are we now? Now I go. You see it?
Yeah.
All right, last time we were talking about the determinant. There's a definition of the gender determinant. Okay, so I will talk about this already. I spent a little bit of time today and talk more about the determinant. What happened to this thing? Jump. Okay. So the determinant has this property you need to know. If I have the two square matrix A, B, then the determinant of them equal the product of determinant. So the proof is very simple actually. But I don't really want to prove here. But simple is simple. It takes a long time. It's using induction. So what that means is you prove for n equal 2 is 2, then prove n equal 1 first. N equal 1, then equal 2. Then assume it's for n equal n minus 1, then you prove for n. That's all. So we also talk about the row operation, left multiplication. We understand more a little bit. So there are several of them. The first one is called EIJ. We already talked about it. So EIJ is switch. Do you still remember it, by the way? EIJ. So what that means is, for example, we have E1, 3. So this will be 0, 0, 1. 0, 1, 0, 1, 0, 0. Okay? So what that means is switch the originally that is 1, 0, 0, 0, 1, 0, 0, 0, 1. This is originally identity. Then you switch the first one to that one. Then you switch that one to that one. You see it? You switch the first row and the third row. Switch. Okay? This is the idea.
Yeah. So EIJ and EJI.
Yeah, exactly. Good, very good observation. EIJ and EJI is same thing. So EIJ, the determinant is -1. Okay, that's easy to see. For example, that one you can easily see that one. The determinant is 1. It's -1. Okay, so EIJ is called row operation when multiple x. What that really means, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's multiply 0, 0, 1, 0, 1, 0, 1, 0, 0 to see what happens. We see it. So you get 7 here because you have that one multiplied. That one gets 7. We get 8 here. Then you get 9 here. See? This one goes to here now. Then you have this one, that one is 4, then 5, 6. This one multiplied that one is 1, 2, 3. So this one is this one. So this is why the switch is switched. Now have better understanding. EIJ is the row operation when multiplied from left. Get it?
Yeah.
Okay, if I take the determinant, now I get 7, 8, 9, 4, 5, 6, and 1, 2, 3. Then determinant equal the determinant of EIJ, which is -1, then times determinant 1, 2, 3. 7, 8, 9. Okay? You got it? Determinant of this equal minus of determinant of this. You got it?
Yeah.
Okay, we immediately have, whoops, why? Perfect. So we immediately have, so if I ask you to calculate the determinant of 1, 2, 3, 4, 5, 6. 1, 2, 3. So what is the value of this one?
0.
0. Good. So because you can write this 1, 2, 3 here, right? So if you switch the first row and the second row, you get also -1 here, and 1, 2, 3, and determinant. And the determinant of 1, 2, 3, 4, 5, 6, 1, 2, 3 is going to be equals minus. So whatever you call this one, you call x, you have x equal minus x. So x is 0. Got it?
Can you just like row 1 subtract from row 3 and then use?
Yes, we're going to talk about that in a minute. That's also good. So you already, Baba. Okay, so if we have two rows, the same thing is 0, okay? Oops, what is this? I should close this section. All right, that's good. Today we'll end at 9:30 because we have to leave very early tomorrow morning. Okay, now we have this one, observation. Okay, for matrix, if I have two rows of 10, then determinant is 0. For matrix, the one row is 0, then the determinant is also 0. Why? Because using the definition, here's the definition of that. If you have, okay, if that one is the page is different. So that one, if using definition, it's going to be 0 times 5, 6, 2, 3, minus 0 times 4, 1, 6, 3, then plus 0 times 4, 5, 1, 2. It's going to be 0. I'm sorry. Here's a determinant. Okay. Cannot do it. Forgot about it. Okay. You see it? So if you have that one is 4, 5, 6, then 0, 0, 0, 1, 2, 3, then it's going to be negative 0, 0, 0. Oh, I didn't read it. Yeah, switch to row and tell you. Switch to row get negative. So, but we already know that 0 is 0, okay? Got it?
Yeah.
So if you have one row is 0, then it's 0, okay? That's all good. I already talked about this. Okay, so now the K, William already said that, okay? So if the ith row times K plus 2J, then the determinant will not change. So this is obviously because determinant is attached one. So that's one. Just like William said a moment ago. So if one row is the multiple of another row, then determinant is 0 because you can multiply that one. For example, first row multiply -2, add to last row, then you get the last row is 0, 0, 0. But the determinant not change, so it's still saying it's 0. Make sense?
Yeah.
Yeah.
Too quick? Huh?
No, I'm good.
Andy, are you good, Andy?
Yeah.
Oh, I lost the color for some reason. So I'm sorry, this is determinant. So equals to 1, 2, 3, 4, 5, 6. Then you have 1 times minus 2 plus 2. Then 2 times minus 2 plus 2 plus 4. 3 times minus 2 plus 6. The last one you get 0, so you get 1, 2, 3, 5, 6, 0, 0, 0. Okay? So you see it? So if one row is multiple of another row, then it's 0. Okay, next one is determinant EKI equal K. Okay, this one, K actually allowed to be 0 by the way. We never. Yeah, even work, even used to. If K is multiple to the i's, then the whole determinant is the K time of determinant of original matrix. That's obviously. Okay. Reprove the following. If one row is 0, then you take the 0 out, then you get 0. Okay. So actually, there are 3 ways to prove that thing. Also, we can prove that if one row is multiple another row, you can prove to be 0. Okay. 3 ways to prove that thing. You get it? So switch to row works. Then whatever. Anyway, it's multiple row. Okay, 2 ways. Okay, with the help, when we can calculate a matrix like this, how do we the determinant? First row multiple minus 1, add to everyone. You get it? So first row multiple minus 1, add to the second, then you only have 1, 1 left. Then add to the third, then have the 1, 2, 1 left. At the last, I have 1, 1, 1 left. You confused?
No.
Okay, now you switch the second and the last row. Why do I need to switch? Because I want to put the last row has 0, 0, 0, 1. So switch it like this. Okay? So but the determinant is going to change to the minus 1. You have to remember it. And then I multiply minus 1 by the last row, then add to everyone. Then I get this. So then the same thing you can, after that, you do in the third row, multiply minus 1, add back to the second row and the first row. Then you multiply the second row by minus 1, then add back to the first row, then get 1, 1, 1, 1. So the last determinant is 1. So we only change the negative ones. So only have switch 1. So the whole determinant of original is minus 1. Okay. Are we good? Right. Also, we're using this trick before we can calculate the inverse. Okay, be careful with this. So the first part is the original matrix. See here, the first part. This part is the original matrix. The second part, actually, I is allowed to do in annotation. I never use it. Okay. Oh no. Not really work very well. Doesn't really work very well. That's all right. Okay. So whatever it is, the first part is the original matrix. What is the second part? Oops. function by itself. What is the second part?
Yeah.
Identity. Okay, so you put the original matrix and identity together. Then you're doing the operation, row operation, which can produce the first part to the identity. Then the second part is going to be the inverse. Okay, that's very, very easy. And then you're doing that, you get that. So the first operation we already did. So the first row minus 1 plus anything, and switch the second row and the last row, then you get this. Then multiply minus 1 by the last row, then add back, then you get this. Then the third row times minus 1, then add back, you get this. Then second row times minus 1 times back, then you get this. Then the last part, that's 2, 0, 0, minus 1, 0, 0, minus 1, 1, 0, minus 1, 1, 0, minus 1, 1, 0, 0 will be the inverse of it. Okay?
Identity?
So the inverse. So why is this? Because, actually just come to my mind. Because A, E together. Original A, original E together. Put it together, then you're doing operation, you same as whatever, then you get E, then something, B. So what is the operation from here to here? So A only A minus equals to E. So the operation is multiply A inverse. So B is going to be E, the A inverse times E. Going to be A inverse. Okay. That's the principle behind it. So why you can get the A inverse because this. So is that right? You can multiply it time. Okay. Try it. So it's going to work. Otherwise, it's going to be calculation is wrong. So this is very, very important and very interesting and very elegant. Very easy, right?
Yeah.
Maybe we should then doing an exercise with it. Okay. Before that, let's say why you need to do the inverse. Why it's so important to find the inverse of a matrix? For example, you want to solve the following linear equation. Okay. Then I can write this linear equation in terms of matrix like that. So 1, 1, 1, 1. So you see that again? Let's see one more time. Compare. You see it?
Yeah.
Okay. The coefficient. Like a 1, 2, 2, 2, and 2, 2, 2. Okay. This just like saying when we learn like saying very, very elementary thing like the saying 3x equals 5, that equation. How do you solve it? Then x equals 3 inverse times 5. Okay, that's the solution. But you get used to using that already. But this is perfect. So right now we have the matrix A, the x equals to something, and B, for example. So in our case, A equals to 1, 1, 1, 1, 1, 1, 1, 2, 1. Is that right? 2, 1, 2, 2.
Yes, right.
So x equals to B equals to anything. Doesn't really matter. B is not important at all. So, okay. So you saw that if you know the inverse, then X immediately equals to A inverse times B. So in our case, equal to something, which is a matrix. Times B, we know that. So what is that? -2 or something? Let's see, I have slide here anyway. So you got x1, x2, 3x4 equal that. Then just multiply it. The inverse, you know that. Then you calculate. Wow, you just multiply it. Isn't that cool? So if you using the elimination or using like substitution, then take long time to solve it. Using matrix is very different. Actually, already know saying why the matrix is so important, because it can help to solve the linear equation. Okay. Good. Huh?
Yeah. Yeah.
The other thing I didn't really tell you is you have something called transpose. Transpose is switch the row and the column. So let me give you some example with it. For example, I'll still doing that one. 1, 2, 3, 4, 5, 6, 9. If you're doing transpose, right now the people like to using the T symbol, T in the shoulder, then equals to 1, 2, 3 is going to be here, 4, 5, 6 is going to be here, 7, 8, 9 is going to be here. Okay? So just switch the row and column, that's all. Then actually nothing is really hard to prove that thing. So AB, okay, I still using the prime that thing as another two notation. Before using prime, A prime, using the transpose. Right now, the people like using the letter, that's okay. Maybe the prime is confused people somehow. Anyway. Okay. Also, the inverse, I didn't really tell you the inverse about it. This is so elementary thing. So AB, if you have A, if A has the inverse and also B has the inverse, then A times B is going to have inverse. So inverse is just equals to B inverse first, then A inverse. So why is it very simple? It's because B inverse, A inverse, this is a matrix. This matrix times AB, that's matrix. So matrix multiplication has association law. This is going to be B inverse, then A inverse, then A, then B. So A inverse A is E, so B inverse N times E times B. So E times anything is nothing. So this is why that is simple to choose, okay? Also, another thing I didn't really tell you, the rank. The rank of the matrix is very important. So how do you define rank? You're just doing the row operation or operation. At the end, you can change everything to 0, either 0 or either 1. Just the 3 different operations. Then count how many ones in the diagonal. I'm sorry. How many ones in the diagonal are in there? Yeah, that's right, in there. So, for example, this matrix has a rank of 3. We can produce something. For example, let's see. Given rank, let's say 1, 2, 3, 4. 5, 6, 7, 8, then 7, 10, 13, 16, then 4, 4, and 4. And then, folks, it's doing simple, okay? So 1, 1. Okay. Let's calculate the rank. So how do it? You can do it either way. So I'm using 1, 1, 1, 1. Then multiply, get everything to be 0. I keep 1, 1, 1, 1 here. Then 7, I get 0, 3, 6, 9. Then I get 5, get 0. I get 1, 2, 3, 0, 1, 2, 3. Then I flip the row and get 1, 1, 1, 1. Get 0, 1, 2, 3, 0, 1, 2, 3, 0, 3, 6, 9. Then I using the second row multiply minus 1, then get 1, 1, 1, 1. Then I get 0, 1, 2, 3. Then I get 0, 0, 0, 0. I multiply minus 3, so 0, 0, 0. Theoretically, yeah, the first, you have 2 rows. Doesn't really matter. So we can get 1, 0, minus 1, minus 2, 0, 1, 2, 3. So 0, okay. So you count how many ones in the diagonal, that's all. So or how many rows is not 0. So this one has 1, 2. Got it? Maybe this is just, I think this book doesn't really have this mostly. Got it?
Yeah.
Yeah.
One thing saying that not everywhere goes to 0, 1, but only the up triangle is called up triangle. You can make the lower part is all lower half part is all 0. If it's not full rank means if you use n by n matrix, if the rank is n, then it's full rank. Okay? So a matrix has the inverse, you find out it's the full rank. You just hear it, okay, right now. So the very important thing about rank is if a matrix has rank n by n has rank n, then it always have a solution. The x equal to b. B can be, B has to be n by one matrix, n row, one column. Okay, x is n by one matrix. How about? Okay, I think another thing I never mentioned is the column operation. So to multiply from right to use column. Operation. So what that means is, for example, let's still see the 1, 2, 3, 4, 5, 6, 9. Multiply the 0, 0, 1, 0, 1, 0, 0, 0, which equals to 2, 3, 2, 2, 6. Okay, so you go to 2, 5, 8. Yeah. So this you see here, this column is the same as this column. See? It looks like this one you can get color.
Yeah.
Oh,
Yeah.
you can get color here. Oh, cool. Oh, I didn't get it.
Oh, you have to right click. Use the secondary color.
There you go. There you go. That's excellent. Okay, cool. We have more color now. That's all. So I didn't really talk about anything about the row operation. So basically, you have the transpose. Transpose essentially translates the row to the column to the row. So anything about the row column operation, you can think about in terms of the row operation. Okay. Chapter 11, we still have the exercise on the matrix determinate. Okay. All right. Let's start with the matrix a little bit. Who has that? Let's start with William still.
29.
54. Huh? 49 is the answer? I don't know.
29.
Huh?
29?
29.
Yeah. I got 29. Yeah, that's what I have.
Okay. Okay. Then it must be true. If so I'm not sure how do you find this one. If you're using the definition, it will be a lot of work, but it's not suggest to use. You should use row operation. Okay, start with Skylar. What do you have, Skylar?
I have 555.
What is 555?
Yeah. Yeah.
What is the same, Andy? Andy, what do you have?
198.
So what do you have, William?
555.
So I think Andy.
Yeah.
Okay, should we look at it or should you feel okay?
It's just tedious.
Tedious. Let's skip it. Okay?
Yeah, I just forgot a number.
Huh?
I just forgot a number.
Forgot what?
I only forgot a number.
What do you mean?
I forgot like to add. I skipped over a number. I was looking at that.
Using row operation.
Yeah.
That would be super easy. Okay. One thing I didn't really tell you is so many things about matrix actually. So we only learn little. So if you have A, then transpose, then still same thing as A. Okay. So if you calculate determinant, you can do it row operation or column operation arbitrarily allow you to do. So whatever is easy. Okay, when we already doing it, and we are doing like a lot of ways. We're doing row operation and column operation all together, but we have to remember what really changed. So for what value will be, this one has no inverse. Now it's empty, right?
-1.
Right, that's William.
Yeah.
Kevin? Kayla?
Yeah.
All right. I don't need to. So now it's back to William. So the determinant of this product CBA
140.
140.
Same.
That's pretty big. Evaluate the following determinant. Giving the answer, whatever, anyway. Now it's Skylar.
I have A minus 1 to the third, and then A times A plus 3.
A minus 1 to the third, then what?
A times 3. No, wait. I have A minus 1 to the third, and then times A times A plus 3.
Okay. What do you have, Andy?
I have A plus 1 squared times A minus 1 squared.
A plus 1 squared?
Times A minus 1 squared.
Huh. What do you have, William? Which one do you agree?
I have A minus 1 cubed, A plus 3.
See, Andy's main exactly right. Okay, so A minus 1 definitely in there, because if A equal 1, this is definitely 0. Okay? A equal minus 3 is also, A minus 3 is also a 0, because if you add A equal minus 3, you add all the columns together, all the rows together. It's 0. So A plus 3 should be in there. You see it?
Yeah.
Okay. It is, huh? Okay, let's do in that in. Add it together. So A plus 3, A plus 3. 3, A plus 3. So these are 1. You can pull the A plus 3 up. It's going to be so if I multiple minus 1, then get A plus 3, then 1, 1, 1, 1, 1, and 0, A minus 1, 0, 0, 0, A minus 1, 0, 0, 0, 0, A minus 1. So everyone is A minus 1. That is right. That is plus 3. So A minus 1. So using all row operation, don't calculate it. Okay? So from today on, now learn how to use row operation to find the determinant, okay?
Yeah.
Yeah.
Okay.
All right. What? This is too tricky. Okay, this time determinant actually. What do you have?
64.
64. I think everybody agree, right?
Yeah.
Oh, that one I have to use the row operation. Okay? William, did you use the row operation?
Yeah.
What do you got?
It would take way too long if I did it.
What do you got?
96?
96. Andy, what do you got?
Yeah. 768. Probably wrong.
What? Okay. What do you have, Skylar?
I have 96. Yeah, I did something wrong.
Andy, probably you did wrong. Okay. So that's only repeated, right? Okay. That one. I think it's Skylar, right? Skylar, what do you have?
I have 3/4, -5/2, -5/4, and 9/2.
3.
I'm the same.
Okay.
Same.
Okay. Find the matrix whose determinant when set equal to 0 represent the equation of a circle passing the point -1, 1, 2, 4. And did you get it? You got it?
No.
That one is the sky, right? Did you get it, William?
I was a bit confused.
Huh?
I was a bit confused on how to do this.
Okay. You got it, Skylar?
Nope.
Okay. So, for example, if I'm giving 2 points, one is x1, y1, one is x2, y2. So find the equation using the determinant about the equation of the line passes x1, y1. So you want x1, y1 here. So x, y have to be make the same column, same row when x, y equal x1, y1. So you have same thing here. So this one is going to be when set to 0, which is an equation of x, y, is going to be the equation of the line. Okay. So same thing if you have the same x1, y1. Why I cannot get the color back anymore? So there's only one. Oh, that's no wonder. Okay. It's no wonder. No, okay. So you want to make same thing. You want to make x1, y1 in 1 here. xy 1 here. x2, y2. x3, y3. But they have to make it's quadratic. So you have to make, so you make x squared plus y squared, x1 squared plus y1 squared, 2 squared, y2 squared, x3 squared plus y3 squared. So when this one set to 0, it's a quadratic equation of x and y. It's this when xy equals to x1, y1, then it's 0. So which means that curve past past that point, also past that point, also past that point. This is unique. That would be the answer. So in our example, it's minus 1, 3 here. So what? Minus 3, 1. That's 2. That's 4. That's 5. It's minus 2. So here is 10. So here is 20. Here is 29. That's all. You got it? You got it?
Yeah.
Yeah.
Okay, let's take a break. Okay? 3-minute break. 3 minutes. Break. What? What did I do? The wrong place. Okay. All right. Are we good? All right. Yeah, it's more than 10 minutes now. So now we already learned analytic geometry for a lot already. So what is analytic geometry? Analytic geometry is which is geometry in the Cartesian plane. So if it's a plane, yeah, you can also go to this is the highway. Oops. Three-dimensional also work. Anyway, it's up to what you think. So that's all about it. So analytic geometry, but it has a lot of things. Hello, is everybody back?
Yeah.
Yeah. Yeah.
Oh, who has the chart? Okay, Skylar. Okay. Now continue. So that's all about about analytic geometry. So you have point. So let's focus on plane first. Plane geometry first. So what is the analytic geometry? What is the analytic plane geometry? Analytic plane geometry is just using a formula. Physically calculate the distance of 2 points, then calculate the angle of the 2 lines, then calculate everything by number, then figure out the geometry property. This is called analytic. So analytic really means you can calculate it. That's all about it. So then so start with the point. So point is just like saying x0, y0. It's just 2 numbers. So it's a line. You have A, you have the B. We used to talking about the plane geometry. We are talking about line segment called AB, right?
Yeah.
So there is a problem with that thing. So when you say AB, something is we actually only mean that physical line over there. So when we talk about number, we say actually AB stands for the length of the line segment. When we talk about in the picture, we really mean that physical line segment. So it's up to what you think where it is when. So there is a big problem with the line segment. So what the problem is?
Your screen isn't moving.
It's moving?
It's not changing if you did do anything.
Yeah, still stuck on the Maple C.
Okay.
Better.
I think you muted yourself as well.
Yeah. Yeah, I can't hear you. You muted.
There we go.
You can hear me now? You could not hear me a moment ago?
Yeah, well, we can.
Yeah, well, just after you switch the screen.
Oh, okay. I'm sorry.
Yeah.
Now it's okay now?
Yeah.
Okay, the line segment we're talking about before. So something wrong with it. What's wrong with it? Does anybody know?
Shouldn't there be like some sort of symbol on the top of AB?
Yeah, we're talking about line segment. We're saying it basically mean that when we talk about like a number, we use like saying we mean the length of the line segment. So something actually is missing from that kind of talking. So do you know what is it? Give me a second. Does anybody know what's wrong with it?
Not sure.
Okay. Okay, we're talking about in a minute. Okay. The missing the direction. Okay. So we should already have it AB, the vector actually. So this has more information. You can talk about the length. You can also talk about direction. Okay. So let's see. Where are you already? What happened? It's explained by itself. So terminology. We already know the point. Okay. We already know the line. Given 2 points, x1, y1, x2, y2. Then we can connect a line. That line, the equation, actually we just had it. The equation is just that equation. We give in the determinant. We can also talk about angle. The angle is, if you have one line, the angle is just the tangent of the angle is just slope. Or you can talk about the angle is the arctangent of slope. That's all simple. We already learned that like many times already, right? Do you have any problem with line, point, angle? Okay. Now it's your turn to figure out it. Exercise 12-1 on page 125. Find the tangent of the obtuse angle. You got to be negative, by the way. Find 2x minus 3y 4 and x minus 3y minus 2, whatever. Okay, it's your turn. Everybody submit it. Hmm? All right. Do we have it? Okay. Somebody has it. Skylar has it. Okay. William has it. And it was yours. Huh?
No.
Hmm? What does that mean? Huh?
I'm not quite sure.
Okay, whatever it is, give us. What do you have? You just saying. You saying give up?
Yeah.
Give up?
Yeah. Yeah.
Why did you give up though? Huh? So they all get the same answer. I think they're right. So you have the first one. So it's 2x minus 3y equal 4. So the slope is 2, 3, right? The second one, the x minus 3y 2. So the slope is 1 of 3. We just calculate using the formula. So whatever, minus 3 to say 1 plus. That's whatever this value is, that's it. Right, guys?
Oh, okay.
I think they get 11, 3 over 11.
Good.
Okay, next thing is about the parameters of a curve. So every curve is one dimension. The one dimension, you only need one parameter to describe it. Maybe this word describe it. Okay? So what that means is this was one dimension. So 2, you need 2. 3, you need 3. Okay? So plane, you're using 2. So that's all about the parameter. So for example, a curve like 2x plus 3y minus 2 equals 0. Then you need the one parameter only. You can say x equals x and y equals to, what is that? So 2x minus 2, 2 minus 2x, and divide by 2. Maybe you feel like it's not good. What is that? So x is a parameter now. Maybe right that way you feel better.
Yeah,
Right? So only one parameter. So one parameter. So circle is a curve. Okay? The curve, then you can make the same. This is x0, y0. So if this is r, then you have x minus x0 equal r. Cosine theta. Maybe r confused you. Let me check it back. Everything back. Cannot back anymore. Crazy. I think this is rule 3 is the point. Then you have the 4 as the radius. Okay. Then it's going to be x minus 2 equals 4 cosine theta. Y minus 3 equals 4 minus cosine theta. You don't have to use theta. You can write x minus 2 equals 4 cosine t. Y minus 3 equals 4 sine t. So what is the t? T is going to be between 0 and 2 pi. So what is the t here? What is t here? T is going to be belong to 0. I mean, no, it's minus infinity, plus infinity. Okay? Got it?
Yeah.
Okay, question. So minus infinity plus infinity, then 0 to pi. So which one is bigger? What do you think?
Can you say it again?
So minus infinity to plus infinity, then 0 to pi. So which one is bigger? Okay.
Aren't they the same?
What do you think? So I can tell you is this one is bigger, okay? This one has one more element than that one. It's hard to explain to you, but you should have the sense is the closed interval is a little bit bigger than the open interval. Okay, so 0 to pi actually has one more element than minus infinity than plus infinity. So how do you see it? We can see it. Huh? Okay. Let's move to the next thing. Okay, we're gonna move to the 2 more exercise. 12-2 and 12-3. Which on the page 126. Okay, you should be able to write to me. Okay. Okay. Random click. Okay, let's do one by one. So 12 times 2 first. Really? I doubt it. Oh, no, that could not be right. Oh, okay. I don't really know the answer, but I feel Skylar's answer is not right. Anyway. Hello, guys. Give up? Oh, give up.
Wait, I'm still doing it.
I think probably we don't have time to. Today we have to end at 9:30. Because we're having to get up very early. Very early. 3 o'clock, get up. Okay. 3 or 4 o'clock, get up. Very earlier.
Yeah, I think we should.
Give up? Huh? Everybody give up? Okay, give up. Give up is easy. Anyway. Why you need to give up? Okay, so 9x squared. Oh, maybe Skylar is right. I'm sorry, Skylar. You maybe right. I missed it. Yeah, I'm sorry. I thought it's plus. You might be right.
Yeah.
Plus 1 and equals 0. Okay, so this one is hard. 9x squared minus 72x. Then plus what is going to be next perfect square? Then minus 4y squared plus 15y plus what is going to be perfect square? So make perfect square first. So you will have can do 9x squared minus 8x and plus 16 with a minus 9 times 16 minus 4y squared 4y plus 4 a minus 4 is plus 16 minus 160. 0. So you get 9x minus 4 squared then minus 4y minus 2 squared. 144, 164, 136 to 0. So you divide by 36. Get y minus 2 squared divided by 9 minus 4 minus 4 squared minus 4 for 1. So the question is using trigonometry. Which one is 1? You see it? So obviously we can have anyway actually, it doesn't really matter. For example, cosine square theta minus sine square theta. Cosine square theta for 1. Okay? So if you keep this one in mind, so you can have y minus 2 sine 3 and y minus 4. So this is your parameter and so you can write y minus 2 as this data as I really don't remember that thing at all. Sectional, co-sectional. Oh, I'm sorry. So what's wrong with it? Okay, are you there, guys?
Yeah.
Okay, the next question. So you have to read it. I told you read it. Otherwise, our next one is what is that curve? You want to do this? Just eliminate cosine theta. Eliminate theta. Okay, get something. Some relationship between x and y. That's all you need to do. Okay, you give you a number 1%. Okay. Mm-hmm. Oh, everybody has it. No, Skylar has it. Andy, only you now. Andy, what's the problem?
I don't really get parameter.
What? Don't find the curve described by those two equations. I already told you eliminate the parameter. You don't understand?
Not really.
Okay. You should look at the example, the previous example. If I told you to read it, you don't read it. That's the problem. Okay. You don't understand the thing at all? Now, do you understand now? Huh? That's so simple, okay? So y equal cosine theta. Then sine square equal 1 minus y square. So it's going to be x equal 1 minus y square over y. That's all. So this is the curve. Everybody has it, okay?
Mm-hmm.
And write x, y equal 1 minus right? Doesn't really matter, okay? Okay, did anybody know what is this? What this curve is? Huh?
Yeah. The parabola,
Is it a line with an asymptote?
ellipsis. Oh, what is that? Hyperbola. Okay, that will be the next time you are answering me, okay? What else? Okay, so this is about vector now. I think vector is a big part about vector. I already told you the line segment really missing something in the direction. So instead of using line segment, we should be using the vector. So the vector is very, very important because you can use it in the plane geometry. For example, plane to prove the median are concurrent is very easy. Okay, you can just calculate the midpoint, then find that point. I'm sorry, this is misspelled. There should be 3 over there. Why is misspelled? Should be 3 over there. Huh? No. What's happening? Something is going on. Hmm? Locked somehow. Whatever. Let's just start with here. Hmm? Hmm? And not. Ah, gosh. What happened? Huh? Huh? Oh, here we go. There we go. Something lonely. Okay. So it's very easy to prove it. Okay. So then another thing you can prove, for example, the attitudes are concurrent. So what that means, if you have the triangle, then it's easy to prove that AD, BC, B is and what? DFC. Oh, that's very interesting. Huh. Anyway, so assume the AD and the BC, AD and the BC. I think is AD and CE attitude. Okay. Huh. Yeah. Then come here. Then here. Then come here. Then come here. Then come here. Then come here. Okay, assume AD and CE are attitude. Then you want to calculate if AC is perpendicular to BO or not. Then AC, oops, went by itself. Then AC, I'm sorry, AC and BO, you calculate the dot product because AC equals AB plus BC. then BO equals BC plus CO. We got it. Then using the BC is perpendicular to CO, so you get sorry, AB is perpendicular to CO, so AB dot CO is 0. Then you get BC dot 0. Then you put AB plus BC back, get AC again, AC dot BC. So then you add BC together, you get BC dot AO. But BC dot AO is 0, so it's 0. So BO is perpendicular to AC. You see it? So the analytic geometry is very, very powerful. Okay. Do you have a question?
No.
Okay. Next Sunday I will not be available, but next Monday and possible available. So if we want to do next Monday, which is Labor Day, we can do it. But I think the next Tuesday is going to be class is going to be started. Okay, let me know if you want to next Monday. Okay, talk to your daddy. Bye. Good night.
Right. Bye.
So